Mr. Minnick helping my Java students learn how to write uh, traditional for loops with the I++ type of thing if given for each loops, also known as enhanced for loops. So here we go. Um, Example number one, we have this for each loop. It has the telltale colon symbol that tells you that it's a for each loop. And the point of it, you can see, is that it adds up all the elements of that one-dimensional array. And let's write a traditional for loop that does the same thing. Well, traditional for loops start with the word for, they have to, and they have a big fat set of parentheses, and they have three parts to the parentheses. And you need to use semicolons there. That's just something to memorize. That's just the way it has to be. So given that setup, and then you also, for good style, should always have curly braces. Even if it's only one line of code, you should just have curly braces for good style. So given that outlying structure, now let's convert the stuff to the stuff. Well, this line of code, let's just assume that's been rewritten here. Test scores, blah, blah, blah. Okay, sum equals 0. Yeah, we need that line of code also over here. Let's just pretend that I wrote that out. Okay, here's the for loop that I need to convert. Well, over here in for each loop world, we usually do not use a variable with a single letter name. I don't, at least. That's bad style in my book. To use I would be horrible style. To use like the variable X is slightly better, but still bad style. Some people use ELT, which is short for element, because these are considered elements of an array. That's still not good enough for me. Because you're like iterating through a for each loop, and you go from one element to the next element to the next element to the next element, and it just knows when to end, because that's how a for each loop works. I often use the prefix next. So if these are scores, I call it next score. If these are like batting averages, I would call it next batting average, and so on. Now the name of the array has to be there. That's just the way it is. Whatever you're iterating through, you have to put that there. This can be anything you want, but like I just said, next score is a good variable name over there. So the equivalent over here in traditional for loop world is traditionally to use an index variable called I. J, K are typically letters also used. Now if you want to, you can declare it right here in the body of your for loop, or you could have done a typed int I equals 0 semicolon up here. I don't really care which way you do it for this problem. I'm going to conveniently just tuck it right in there, the declaration. Now I do need to set it equal to 0 because these array elements are always behind the scenes numbered from 0 up. So that's just a no-brainer. And in a traditional for loop, you're going one by one, but you do that by controlling how you are iterating through these index positions. So you need to do I++. If you're dumb, not dumb, but if you're just like bad style, you would write I equals I+1, which is just a long way of doing I++, so we don't do that. Now, if you are using a traditional for loop, you got to end this process intelligently with the control expression here that becomes false at the moment you need it to be false. So the way to do that would be to possibly have I less than 5 here, or I less than or equal to 4. But then you're hardwiring this for loop to this specific version of test scores that happens to have a length of 5. That's bad style. They would probably take points off on the AP exam if you did that. And so we're not doing that here in this worksheet. We are using the better version I strictly less than the name of the array, test scores, dot length with no parentheses because length is a public instance field in the array class. Now you could also do I less than or equal to test scores dot length minus 1, but that would be that's odd. So this is the way it's typically done. So there you go. We have just basically converted the header of this for loop to the header of a traditional for loop. The body, well, it needs a little bit of work also. You have sum plus equals, that's the same, because the variable sum is just a container variable where you're storing this accumulated total. But next score only exists over here because it was declared as an int in the body of this for loop. Here, I isn't actually taking in on the numbers 89, 95, 76 like next score is over here. I is just iterating through these subscript positions. So the name of the array, test scores, square brackets I. That's the key to the final answer here, semicolon. If you just had I here, that would be stupid. You're adding up 0 plus 1 plus 2 plus 3 plus 4. And you can't put like the number 0 in there because then you're just adding up 89 over and over again 5 times. So there you go. That's the answer to number 1. Exercise 2, because it's a two-dimensional array, it's a bit more difficult to translate. Let's begin. Well, because we have 2 for loops here, we're going to need 2 for loops over here, nested, of course. And they're traditional for loops. So you would have a big fat set of parentheses with 3 parts, separated by semicolons. Never put a semicolon out here. Never, ever, ever. That would be so stupid. And then you have curly braces for good style, nicely indented and all that. Sum equals 0. Let's just pretend that line of code is over there, and let's pretend that this declaration and initialization statement is also over there. Okay, so here, if you truly understand the difference between the outer loop and the inner loop, you'll understand that row happens to be a variable name that takes on an array of ints, a one-dimensional array of ints. So at first it's this, stored inside a row. Then that gets overwritten the next time the loop iterates with a 958, all plugs in for a row. This guy, next score, he is just an int each time he is overwritten. So he goes from 6 crossed out to 8, crossed out to 7, and then the next time around the outer loop, he takes on the 9, 5, and 8. Now all of these numbers get added into the running total sum, so this works fine. But if you were forced to rewrite it, or just to understand both of these kinds of loops well, you should know how to rewrite all this. So here goes. We don't use the variable row over here. That would kind of be awkward, at least not in the same way that we're using it as an array of ints. So over here, it's quite traditional in my classroom to actually use the variable name row here and COL, short for column, here. Because if you think of this the way a human would, you've really got a two-dimensional array that looks like a matrix, to what math teachers call a matrix, with rows and columns and all that. So row equals 0, that's the loop variable that's taking you from this 0 to this 1, and column equals 0, that's the variable that's going to be iterating from 0 to 1 to 2 through your 3 columns. And of course you'd have row plus plus here, and you would have column plus plus here, and that's just good normal conventional style. Here, this is the only tricky part that we have to worry about pretty much. Here, you're talking about the array scores, which is one array that has 2 positions and therefore a length of 2. So row, the variable row, less than 2. Oh, but that's horrible style. We really want to make it so that it's named scores.length there, because then it works for any array named scores, which is more flexible coding. Here, the columns go from 0, 1 to 2. So you could do column less than 3, but you'd lose points on an AP exam or pretty much anything that you ever hand into a university college professor. And instead of 3, we've learned that that should be scores.length, but it's not the length of this outer array scores. It's the length of each element that's stored within these 2 specific positions. That's a length of 3. So that's really scores, square brackets 0, and then the dot length of that is 3. Scores, square brackets 0, dot length. We've already studied this. It's very important that you get this notation right. Square brackets 0 here, no square brackets. Now if you're Mr. Fancy or Mrs. Fancy, instead of a 0, you could actually put the row variable there and it would work quite fine for ragged arrays where the length of this first row is not the same as the length of this if that didn't exist. We don't cover that on the AP exam, so just put a 0 in there. It's always safe. Okay, so how do we add all this up? We do sum plus equals, and we have the name of the array, which is scores, square brackets, similar to what we had to do up here. And we have 2 sets of square brackets. It's such a common mistake that I see that even though you have a 2-dimensional array, some students just put 1 set of square brackets there. And it's always rows and columns. And because we use the nice variable names row and column, it's just easy to read the code, row and call. Instead of like I and J or just R and C even, it's just row and column, it makes sense. There you go, there's an answer to number 2. Number 3, I might not do the whole thing here for you, but it's because it's so similar to what we had up above. We have double nested for loops again, like up above. And we use, I'm going to use R and C this time to save time. And we initialize them to 0 each because this algorithm, if you traced it, it just finds the maximum number there, which looks like it ends up being a 9. But we don't know that yet because we're not human. A row is less than, we have the same notation there. Should be plugged in there. I'm not rewriting it. Oh, sorry, my bad. That's actually what should be in there. And the notation that we had right here should be plugged in, right here. So you rewrite that. This would be row R++. This would be C++. And then this column equals 0. That actually would need, oh yeah, good. It's good I used the C there because that is keeping track of what column we're in. We actually don't need that in this corresponding version. You'll soon see, hopefully. Instead of next score there, we don't have anything over here, but we would need an if statement. So if, now if something is greater than max, we do need the variable max. This max was equal to 0, and we do need these two variables to be set equal to 0 in this version. I don't think we need that variable or that variable, and we do need that variable in existence. And so in the conversion here, we still need an if statement to find the max. This is a linear search through a two-dimensional array. If next score greater than max. Well, just like the previous exercise, next score is illegal in this version. We would have if scores square brackets R square brackets C, kind of like we had substituted right up there, is greater than max. The variable max does exist and is necessary down here. So if that if statement is true, these 3 lines of code would have to be written here in the body of this if statement. Max equals, again, instead of next score, just like I didn't use it there, I would need all this. Max equals scores RC. Sorry for my sloppiness. This is hard to draw with a mouse. And then we still need these 2 variables that keep track of what row number and what column index position number we found the current max. Well, row here, as I was updating it manually in column, is already part of the setup here. It ends up being known as R down here. And the current column where the max was found would be equal to this C variable, because that's just being kept track of by the nature of a traditional for loop. And we do not need the column plus plus over here because that column plus plus is already here. And it's done. I have now rewritten a linear search through a two-dimensional array for the maximum integer as a pair of traditional for loops.